Hello, everyone. Welcome to the December 8th, 2021 meeting of Sig-Auth. Looks like we got a couple items on the agenda. Let's start off with this announcement, Mo. Is this you?
Yeah, you want to open up the, that's some tiny text. So yeah, myself, Rita, Anish, and Natalie, we sent this out, I guess, yeah, almost 10 days ago now. And we got some good response. And if you want to open up that needs kept link, I was just going to do a quick highlight reel of what's on there. Just to give this some more awareness. I don't expect folks to be working on this, near the end of the year, but hopefully folks that are interested will be able to pick up some of this work next year for 2024 timeframe. So Anish and Rita have been sort of leading the KMS work. There's a few folks that have said that they're interested in collaborating. I think we were going to try to send out some kind of doodle to see if we could have some high bandwidth meetings on what we're thinking needs to be changed and updated in that API. So if you're interested, probably ping Rita or Nish, so that way we have a sense for who wants to be involved. I suspect this to be a pretty large effort, but I think there's enough folks interested to move it forward. The next two KEPs on that doc that we have written out are similar in the sense that they both talk about configuration options on the API server that are owned by Sig-Auth that are flags today, and we want to upgrade both of those implementations to structured config. And various folks have indicated interest for both of those items. So that's good too. I think this one is less maybe fleshed out than the KMS stuff. I don't think we've discussed this as much. So I would expect these to start out more as higher level designs, and because I don't think we've talked about either one of these in a Sig-Auth meeting before directly. We just had like issues and asynchronous conversations about them. So both of those are up, and then the bottom two ones are sort of placeholders for things that we have that are within Sig-Auth's purview, but we haven't fleshed out enough details for someone to maybe write a KEP. All of these are targeted at, someone has to basically sign up to write the KEP, and also maybe ideally the same person, but maybe someone else also signs up to write the implementation. We are asking that the release that a KEP is marked implementable, that same release or the next release should involve the work for that KEP to be started, so things do not get stale. We want to keep this moving. And also, just at the high level, for anyone interested, this is a pretty high bar. This is a long-term investment. It takes a lot of work to get these things through. So just know that if you sign up for any of this work. I would firmly put this as not the getting like good first issue type of category. This is like the exact opposite of good first issue. I think that's all I wanted to say. I don't know if Rita, Nish, or Natalie, you guys have any thoughts or comments on this right now. I plan on continuing this discussion, next year, since this was our last meeting, but I just wanted to try to raise some awareness here.
Just for a concrete timeline, I would guess that the enhancements freeze for 124 would probably be late January. I think the last time I saw the release team was treating beginning of January as week 1 of the release, and the enhancements freeze is typically like week 3 or 4 of the release. So if there's going to be a KEP for these targeting 124, I would expect to have it reviewable like at the beginning of January, so that there's time to iterate on it and close on questions to get it implementable in time.
Yeah, it's pretty tight with holidays, so I would be very surprised if any of this could be done that quickly, unless someone was just doing only that as their full-time job for the first week of January. So, but my hope is that even if we don't get any of this stuff in as implementable by enhancements freeze, that we could get it in as a KEP that can be worked on in merged and worked on in 125 timeframe. Because I think we've talked about this stuff ad hoc for a long time, but we haven't made progress. So it'd be nice to push this forward.
Sorry, just to confirm, you said to make sure that it's reviewable by mid-January? Early
But
January.
It depends on how good of a chance we want of the reviews and iteration wrapping up in time to get it implementable. Like,
I mean, we have
obviously
to be realistic. Yeah.
Yeah, like if a KMS like rework comes in like mid-January, I really doubt like it would get attention and feedback and be able to iterate and actually close and be implementable by like a week later. So
Gotcha. Okay, so I think the TLDR here is if you wanted to be meet the 124 deadline, then it really should be reviewable by early January.
yeah,
I think that's fair.
and like it's better to aim for early, and if it doesn't make it, that's okay. At least we made progress. Like what tends to happen is we think, oh, we're not going to make the 1 dot whatever enhancements freeze. That's cool. We'll just do it for the next one, and then a whole release passes, and then we're in the same boat. So it's better to like get it up there and get it reviewed. And if it happens to miss 124, that's okay. We've made progress, and we're like in a much better place to get it for 125. So.
That did remind me of something, Jordan. So, the top 3 on here, I'm interested and willing to review for. I think once we get to the stage of having KEPs, I think we would need some folks to at least volunteer to review and be involved, other than just myself. I think David's on the call. I know, David, you had expressed interest in the authorization one. I don't know if you'd be interested in that.
Yeah, I am. Adding a second authorization hook early.
Yeah, if we want to go ahead and add names to people who are interested reviewers, that would maybe be helpful. And if you're constrained to like reviewing 1 or 2, maybe note that so that we can try to load balance and just make sure we have bandwidth.
That's a good point. And yes, I am.
Natalie here. Should we also be noting in this doc, this is more a question for Anish, Rita, and Mo, maybe we should note like just expectations for folks working on this. If we want this in 124, then by end of the first week of January or early January, we need the KEPs kind of in a draft state for review.
Yeah, I'll add that to this doc at the top.
Yeah, sweet.
Cool, thank you. Anything else y'all want to discuss about this? We have, I think, a few other items on the agenda on this.
Awesome. Thanks for putting this together, Mo and Rita and whoever else worked on this. All right. Moving on, client go TLS config for ciphers and min version. Mo, do you want to?
Yeah, I want to bring this up here. So I brought this up, I don't know how many weeks ago now in API Machinery, and I spoke with David and someone else for API Machinery in regards to basically in client go, I wanted the ability to configure the TLS stuff more specifically. So today it hard codes to TLS min version 1.2 and no control over Cipher Suite. I wanted more flexibility there. So I don't know why I started with API Machinery first, but I did. So that's there, and the TLDR there I got was a relatively positive response with a desire to be able to configure it, like override the default globally and then explicitly override it at a REST config level, so that Yes, David, you are friendly. Why wouldn't I? But I think, such a configuration is effectively co-owned by this SIG and API machinery. So I wanted to ask here what folks thought. Like, for example, I don't think, Jordan, you were there when I had this conversation with others. So I'd be interested in your opinion.
What are you talking to? Is it always Kube API server?
Not necessarily. So that same code is used for webhooks and other things. So I would like to be able to enforce things, and also there's a lot of code within our like API server logic and aggregated logic where all the client stuff is like 18 layers in. So like having like the ability to globally override it to do something else would be helpful, because most of it's not exposed in any reasonable way. But at the bare minimum, I would like to be able to, at least on a REST config that I create, be able to set configuration. So at a very high level, what I thought of for configuration would be a min version, which would probably only allow 1.2 or 1.3 to be set. And then when it is 1.2, it would let you control the ciphers. It would obviously not let you control them when you have 1.3, because Go doesn't let you do that. So there isn't any point in that. Does anyone have thoughts or concerns? We have roughly similar configuration for the API server itself as a server. I'm basically asking for similar configuration as a client interfacing using our machinery.
Do you want to set them, or do you want to turn specific Cipher suites off? I think there's like a subtle difference between those two.
So far, the way I've built most of this stuff is I just set the ones I want and explicitly disallow any ones that I haven't explicitly picked myself. That way there's no surprises. Granted, I don't think the TLS 1.2 Cipher Suite is actually growing. I think that's done. So maybe
the Cipher Suite aspect seems sort of like a dead end, because it's TLS 1.2 only, and then 1.3 and up, it doesn't apply. Like I don't see that growing. I don't know. From an auth perspective, I don't object to setting these. Like, it seems like machinery owns most of the plumbing there. I would probably not want to expose these all the way out to like kubeconfig files. That seems super fiddly for that level to be managing. But if you're doing it programmatically, like, you can already override the client. Like, why not? Why let you plumb this parameter? I don't know.
Yeah, the client configuration, like in my case, because I was using the code in a bunch of different ways, I was basically trying to not reinvent half of client code and all the nice wrappers and all those things, because they're useful and nice. I don't have an opinion on how far up it goes for like kubeconfig. My gut says that I talked with Sig-CLI a little while back about having a kubeRC file, someplace to have configuration that is outside of a kubeconfig that's for a user. I could see maybe some value there for something like this, for a user to explicitly say, I refuse to talk to servers with crap ciphers. But that's just like a vague thought. I wouldn't tell anyone to do that. But David had asked me to write a KEP to flesh out the details. My thought process on that was I would stop at the REST config level. I wouldn't go further up unless anyone wants me to really badly.
I think it would be possible for kube control to control this setting without adding it to a kube config if Sig-CLI felt strongly about it.
Like flags?
It could be done that way.
Okay.
It doesn't have to go to a kube config.
Oh, like you could even be like nvars, just like.
Yeah, I know that would drive some people a little bit batty, but it would be a kube control, presumably only thing. but it wouldn't have to be a cube config. But I would probably try to argue about how far up the stack it goes after the core library made it happen. And a comment about FIPS compliance. When I've done FIPS stuff, it has been the case where people want to just completely remove ciphers from the OS and from the libraries. Like there's a special OpenSSL or whatever it is at Born. There's a special SSL package that you end up using. So you can't have this be an accident in FIPS compliance.
Is
Yeah,
that
on
the
the client
motivation?
side, on the client side, to do FIPS, you can actually build with the FIPS Golang toolchain, and if you want, you can import a FIPS only package, which like puts the TLS stack in a mode where it will refuse to talk to anything that's not FIPS compatible, and it does really weird and unpleasant things like reject talking to servers with keys that are too big because they were bigger than what was permitted the last time that stack was FIPS validated. It's really unpleasant.
Yeah. So that certainly is part of my motivator. I also just in general wanted more control on, just to assert the set of behaviors that I'm expecting out of sort of the stack. Certainly FIPS is a motivating factor. I've also because people are bad, I have FIPS requirements that are like, I want FIPS, but like not all of the FIPS, so can't like import the FIPS only thing. I have to like control how much FIPS only it is, and it's just my life is very unpleasant. So I Ted, I can't hear you if you're saying something. I think you're angrily commenting, but I can't hear you.
Yeah, I don't think this seems too objectionable. I would say that if we have two allow lists, one from the Go standard library and one from command line flags that exist in some configuration file or in kubeconfig or scattered all over the place, then I worry that those windows will move over time and then there won't be any intersection and stuff will just break, versus like a mode where you selectively turn off Cipher Suites. You don't have to worry about that. Like if we configured deny and you used it, if there was a problem with some TLS mode that you wanted to turn off before Go gets an update. Maybe that's not a concern since we just got TLS 1.3 and everything's going to be static for a little while, fingers crossed, but yeah.
Of course, if you're using FIPS, they'd make you turn off TLS 1.3. So there's that. But okay, so I think the gist I'm getting is like I could actually go write a cat and get it reviewed by interested parties, and I think we'd be okay. Is anyone interested in being a reviewer on such a cat? Any chance?
I am.
Okay. Mike, do you mind writing that down on this stuff? So I remember that David volunteered. Cool. Does anyone have anything else on this? Is Adam? Adam, are you on the call for your topic? See Adam. Maybe he forgot that he's on the.
Okay. Does anybody else have context on this?
I do. This is about the trying to find a way to enforce some limits on ephemeral volumes. So when we created pod security, we said we were going to make it allow ephemeral volumes for CSI drivers for all levels. That's restricted, baseline, and privileged. And doing it in that way allows CSI driver authors or anyone to create an admission plugin that provides further restriction. If we had chosen to go in the other direction and restrict inside of pod security admission, there would be no way to have a special set of rules for each one. So one of the things that has come up is that some kinds of ephemeral volumes are safe for use by restricted users, and some types are not. While it is possible for every CSI driver that is not safe for use in ephemeral volumes to add their own admission webhook and manage that webhook to prevent usage by restricted users, there is also an API resource that gets created for CSI drivers that is a convenient spot to hang a description that says either I'm safe for restricted users or I'm safe for level X. And if we were to do that, SIG storage, as I understand it, last time I spoke with them, they were amenable to the idea of actually owning that admission plugins. This is not an extension, or should not be an extension to pod security admission, but it would be a new admission plugin that can say, I can recognize this CSI driver as unsafe for restricted users, and therefore I will not allow its use as an ephemeral volume in a restricted namespace. I think the desire from the storage folks is to have blessing to interpret the namespace label provided by Sig-Auth, right? That label is pretty clearly, I say ours, but they would be consuming something similar, or they would be consuming the same thing and having it apply in their admission plugin.
Quick question, David, is so I understood sort of why we went with the label-based approach for on namespaces for the new pod security stuff. You know, there's just a lot of nice UX things, especially around dry run and other concepts that kind of allow that to be really useful.
You're saying for a CSI driver, why have a label instead of a first class field?
Yeah, that was just a question. I don't actually have an opinion. I was just curious, what was the reasoning in this particular case?
The reasoning for this particular one is that the prototype was built with a label because labels don't require schema change. I don't believe there would be a principled objection if the approach was generally blessed to adding an actual spec field.
Stepping back just a second, I had thought when we were talking about whether to allow ephemeral CSI drivers or not, when we talked with Sig storage at that point, I thought the direction was to recommend that unsafe CSI drivers not be modeled as like ephemeral inline pod drivers. Isn't control over those parameters, like control over unsafe parameters fed directly to a CSI driver, like there's a way to protect those with a storage class so that you capture the parameters and then things inside namespaces consume it in a safe way. I thought the guidance was to not create unsafe ephemeral inline CSI drivers.
To my understanding, some already exist.
Can we get help me anchor my thoughts about this? What is an example of an unsafe ephemeral CSI driver? Like what is the bad thing that can happen?
It depends on what the CSI driver does, right? So imagine a volume plugin that is going to like issue kernel commands. It takes as input from the CSI parameters, like things that translate directly into those kernel commands. So it's not hard to imagine like providing inputs that would crash the machine or like do really terrible things for performance or like who knows. And so when the values for those parameters are coming from a storage class, it's a more reasonable assumption that like the cluster administrator set up that storage class and said, like, I'm driving these unsafe parameters, but I'm selecting the values to set there. But if it's being driven from inline pod specs, then any random pod author can say, hey, please give me a volume, and I can set any parameter I want, and it feeds directly into that driver.
And
It's
so
like
if
a
you
bad
were
idea to
starting,
write a inline CSI driver like that.
That consumes parameters that are unsafe or not checked or not bounded.
Yeah.
I agree, and that's why that's where I thought we ended up when we talked with Sig Storage about the pod security standard stuff, which is why, like, I'm kind of questioning, like, if you were going to write unsafe CSI inline ephemeral drivers, maybe this would be a reasonable way to protect them. But I thought that they had swept and identified there were only like 1 or 2, and both of those hadn't really considered their use. And so I'm just wondering if that changed.
well, to my knowledge, it didn't, and they still exist and are still used. It's possible that I'm out of date there. I didn't see I don't recall seeing changes in that regard.
All right, let me see if I can dig up the Sig Storage meeting. I think there were a reference, and maybe Michelle went and swept the list. Let me see if I can dig that up, and that would maybe be good to settle. Like, would it be less work and a better long-term direction to encourage the couple ones that were identified as being unsafe that this isn't a great use case, and see if it would be reasonable for them to reposture those
and come up with some plan to prevent their use in upgraded clusters.
Yeah.
I'm open to that if it's practical to do.
Okay, I'll take that AI to dig up those references and see if we can pull in Michelle or I think it was Michelle who did this week, but pull in the storage leads and double check that this is necessary.
And so conditions on necessary would be if those had not changed, were known to be risky, we will need something to deal with them. Now we could say, go off and build admission webhooks for these 2. We could say, we've identified these 2, we're just going to block them. We could say, we've identified 2, we don't know what other ones have been written. Here is a way to explicitly indicate I am not safe.
Are these ones that we've identified third-party CSI drivers, or are they something shipped by the Kubernetes product?
They're third-party CSI drivers. If it's a handful of third-party ones, and the recommendation is that unsafe CSI drivers not be made, I don't really want to build in a mechanism for making it easy to create new unsafe CSI drivers and then like integrate with policy stuff.
When you consider whether those CSI drivers are likely to provide a safe way in general, it seems like the answer to that would be a resounding no. And so you would be condemning the people using them to have to build their own validating admission webhook. And you could say that, but it doesn't seem awesome.
I mean, I guess to me, it sounds like this is a bug report or CVE on those third-party drivers. You know, you have built one that can be used inline and accepts untrusted commands from an untrusted user.
And this isn't new. Like, to be clear, this is This is something that already existed. If they're unhappy with users having access to these unsafe options, they already had access to the unsafe options. I just don't think it's our gap to close, honestly.
If someone were to close the gap, you would probably expect them to build it in nearly this exact way, correct?
I would probably expect them to close it by not publishing, like not consuming unsafe parameters from pods, not consuming it, but then trying to fence off.
I'm thinking about a cluster admin who has this in his cluster already and is trying to figure out how to move towards a best practice. And he can look at it and say, I need to keep this problem from getting worse, but I can't change it today. How can I do this? And we can say you have to build this from scratch, and they can.
Yeah.
I mean, if we found a bug in some other third-party component that's deployed, we wouldn't build a pod security policy extension to blacklist that, right? We would say, go upgrade your third-party component and then remove the old
I
version.
would not leave OpenShift clusters vulnerable in the time frame it takes to do that. I would give them a mechanism to stop the bleeding now.
I mean,
now
like,
if
the naive way to stop that is to say, all right, this problematic CSI driver has a default quota of 0 on it. So no namespace can use it by default. And I will look at the ones that are currently using it and then like grant them exceptions and open it back up to those namespaces. And the new namespaces won't start using it. And I'll burn down the problem I already have. I mean, quota is not a great, like, I wouldn't go to that as a design for this, but as a stopgap, like lock it down and then make exceptions for existing users, it works.
So it sounds like it doesn't matter to you how many of these there are. I just want to make sure we're grounded in that fact. Like, it doesn't matter to you how many there are. We're just looking for completeness' sake.
To me, it seems like an anti-pattern to intentionally expose consumption of unsafe parameters into pods. Like, there are a lot of things in pods that we wouldn't do the same way if we were going to do them today. And ephemeral CSI drivers are brand new. Like, they just shipped last release or like a couple of releases ago. So they're just in the like picking up use phase. This seems like the right point at which to say, don't expose any functionality to pod authors that you consider unsafe. Like, this seems the right point at which to do that.
Thinking. Trying to decide how and why it would be different than be perfect, but I will probably just continue. I suppose the list is useful to know in general. And then building it out so that the option is available would probably be enough for me. I mean, it is possible to do it. I feel bad.
I mean, as a stopgap, couldn't we ship like just throw up on a repo somewhere an emission webhook that detects unsafe usage of the known unsafe inline CSI volumes?
Yeah, I mean, that's exactly what this does. So it's just a question of
this. Well, the proposal, the way it was in the doc, was like building some field or additional capability into pod security policy, right?
it was supposed to be channeled through a new admission plugin built on top, right? Like it's very easy to create a PR that does that. I would not support adding this to pod security. I would support building something in to actually make this configurable entry, but lacking that, someone can manage it through validating admission webhooks. I just would look at that and say the cases where you're likely to need this are not the places where the person has already built that validating admission webhook for you.
I guess what I mean is, as Sig-Auth or as Signode, we would say something like, we're aware of these 2 cases or 3 cases where people have written CSI drivers that can be used as inline volumes, and they accept unsafe parameters in an untrusted fashion from the pod. We have filed bugs or CVEs or whatever against these. In the meantime, here's a stopgap admission webhook that will block usage of these.
Right. It's you can actually make that block usage something that is first class, present, always on, and you add a label and you have fixed your cluster in the field. And I look at that and say, am I likely to build that? Yeah, I'm 100% likely to build it. The question is whether I would build it upstream or downstream, and this is effectively the offer to put it in upstream.
Yeah, I think I don't want to encourage people to write unsafe CSI drivers and then distribute a manifest that has a label and think, oh, because we put this label on, it's totally cool that we wrote an unsafe CSI driver. Like that seems like that's what this would motivate going forward.
Yeah, I guess that's just a matter of perspective.
Yeah, until we have examples, it feels like this is a pretty hypothetical discussion. But I think examples would be very helpful. Should we have a couple more items on the agenda. Should we reconvene, maybe discuss on the doc a little bit?
Sure. I will have a look at the list that Jordan put together. And
reconvene in January.
Sure.
Awesome. Mo, next 2 items look like they are yours.
Cool. Let's see. You got 20 minutes yet. So I want both of these to be kind of quick, but I know we've talked about this on and off for a while, and I wanted to see if we could sort of try to write down the MVP requirements around client certificates for Kubernetes service accounts and like serving certificates for Kubernetes services. That's like the bare minimum we could do here with no spiffy, no fanciness, just the bare minimum X509 semantics that we all understand, or the API server already understands.
I have been meaning to write a KEP for the client certificate piece of that. I've just not had the time. But
Yeah.
Since someone is interested, I can actually do that. Basically, what I was going to propose was kubelet volume sends the standard CN format that we already have today to a designated signer, and that signer can be the existing cluster certificate signer. And then you hook those two up and you get a client certificate.
How do
In
you
your pod.
plan on enforcing the boundness of bound tokens to bound certificates?
Which binding, the pod one?
Or the secret one, or just anything we come up with in the future, right? But today, the token authenticator for service accounts is what enforces. Well, first, it's what expresses the extra fields that contain that information and also enforces that they're valid. Client certificates today, with the schema that we have for them, lack the ability to express the UID or an extra fields of service accounts, and they also, just the way they're expressed, do not have. They would not, like, if you created such a certificate, like pretend you just could today with all the fields set, the token authenticator for service accounts would be unaware of that and does not validate that the pod reference, for example, matched the existing pod with that service account, et cetera, et cetera. So I think these are all tractable problems that are not necessarily hard. They just need to be written down as, like, this is how we plan on solving it. And generally speaking, that's what I would want. I guess I don't really have an opinion on if it's a new signer or the existing one, as long as it functions. Certainly the existing signer can, if you give it the right CN, will express the service account name, and Kubernetes would not really care. It's just that the UID and extra fields aren't expressed or enforced correctly.
Yeah, I think what I was thinking of was just in the treat the CSR as not really a contract for the shape of the certificate you have to issue from your signer, but just a cryptographic proof of the identity of the pod requesting the certificate. And then, the default signer that we already have will respond with one certificate. If other people like other formats, their signers can respond with other formats. So yeah, I don't know. I can do that surgery to extract the kubelet piece from the existing Google Doc and bring it back at our next meeting.
I'm not sure if I fully followed exactly what you said. Like, I guess I don't necessarily care as long as the enforcement is still there. As long as the protections that we provide for bound service account tokens, right? Like, in particular, bound service account tokens, even though they're JOTs, are still revocable, right? Because they reference objects within the API that we can look up and revoke them using. And I would want that same property for these certificates, even though we don't have, like, CRLs or any mechanism to vote certificates in general.
So are we only talking about clients of the Cube API server? Well, how do you want these client certs to be used?
Yeah, clients for the API server. I mean, today we don't enforce any particular trust chain requirements. So that's where the new signer could be beneficial, because you could explicitly say that that new signer should not overlap with any, should not, but is not enforced to overlap with any other existing signers trust chain. So that way you could keep them separate if you wanted to, which is what I would want to do, I guess. But I mean, I guess I could live without that also. I just
My thinking was to focus. Sorry.
Go ahead. Go ahead.
Oh, I was just saying, my thinking was to focus on the kubelet piece first, because the feedback I got before was we need to focus on one piece of it first, and the kubelet is like the actual requesting of the certificate is the most concrete piece that can be landed first. And then, we can work on, okay, Cube API server should enforce some more requirements, like object binding, for example, on the certificates that it expects. which I agree is a
That
simple
makes
thing.
me nervous because that sounds like we have an intermediate state that's unsafe.
It's not unsafe. It's the same safety we have today. Today, you can go off and, with some difficulty, request a certificate for your pod and use it, and it doesn't have object binding.
Or, yeah, I mean, that's what I mean. Like that you
But we
have
don't
to
give
do-
it one automatically.
Yeah, that's the part. That's what I'm saying.
Okay.
Yeah. Like
And
you can do bad things if you have enough like time invested in the bad things. I'm saying like I would want people. I don't know what the mechanism would eventually look like, but I would want people to be willing to have this basically on for all pods all the time with no qualms.
Yeah, and I was thinking about automatic issuance. Don't think about that for now. Just first, let's talk about how we actually get the certificate into a pod. If someone is willing to, you know, write a projected volume or whatever, then do the other steps in that process, where we eventually end up with everybody getting a nice secure certificate by default, and you don't have to use bearer tokens.
I guess I could ask, could we go the other way? Could we pull out the object binding validation that we have out of the what's its face, the service account token authenticator into a generic layer above an authentication, and then come up with a schema for full expression of all the user info fields for certificates? If you have that, then your API server is now ready to, regardless of how those certificates get created and made, enforce the same validations. And then,
I mean, it's not particularly complicated. But
well,
yeah,
I
we
know
can.
it just does. No one's tried to write it down well enough to get it through into a KEP in anywhere, right? That's what I mean. Like I think we talk about it, but we haven't made progress. So I'm trying to like go from tiny pieces that I don't think cause contention of any sort, really.
Yeah, so I guess I think that client certificates for the Cube API server are, as far as like KEPs go, feels lower value to me than support for MTLS workload to workload within the cluster. Yeah, so I guess like, you know, if the tokens still exist, like what problem are we solving by pursuing this? And I guess if it's just to get our foot in the door, then are we actually really getting our foot in the door towards, you know, like maybe higher value improvements down the line? Agree or disagree?
I think object binding on a certificate is like, it's pretty easy. Like we could just, I don't know, like we could extend the existing MTLS authenticator pretty easily to support optional object binding on the certificate. Like, you know, we'll have to do some dance to get an appropriate OID to store this information under in the certificate. But then we can just stash the pod UID in there, right? And slice and dice our existing object binding code for the token. So if that is valuable, we can just, I think that's kind of like unconnected or unordered with the rest of all the certificates work. Does that make sense?
David, I saw you unmute a few times.
Yeah, I mean, I did think we were trying to separate this into pieces so that it could land in smaller chunks. And I thought one of those was you needed to be able to have a serving certificate for all services. And we agreed that one was the easier problem. I'm trying to understand whether, Mike, your suggestion is to actually go back to trying to do it all at once, because I feel like that got bogged down in like
No,
it's a
Client certificate for all pods or serving certificate for all services? Because I don't think serving certificate for all services is a very easy problem. that's a very difficult problem.
So my comment was only on this discussion field, like it was focused primarily on mutual TLS2 cube API server. That seemed like between mutual TLS between pods or serving certs for pods for other things to talk to them, that felt lower value than the other potential motivations. We have like a reasonable story for authentication to the Cube API server already. So I would say maybe we should prioritize the others unless this is like a clear avenue towards achieving the other goals in short order. Do you buy it, David?
As long as there's still some iterative path where it's
right,
it's like an on ramp and not an on cliff, because I want to make sure there's some way that we can look at it and say, yep, we can fit this much in this time, we can fit that much in the next time, and rather than just keep saying, no, you can't come in because it's too big a change all at once. So yeah, as long as that's still there, then yeah, I'm okay with that.
So Mike, the piece you thought was most valuable was MTLS between Kubernetes services on like a single cluster.
Yeah.
So meaning we would need the serving certificate bit for the services and client certificates for the service accounts, those two things together.
Yes, well, start making progress towards one of those. It seems like our discussion was kind of around authentication to Cube API server only, or what we would need to bring MTLS to Cube API server up to like parity with branch service account tokens.
Okay, so like as a very smallish starting point, then could we attempt maybe just I guess I'm not necessarily falling to here where you said that serving certificates for all Cube services is hard. I feel like this is a thing that David built years ago in OpenShift. I just want the same thing basically.
So the problem is service lifetime is totally decoupled from pod lifetime. And the membership of pods and service accounts backing a service can change at any time in a very fluid way.
Mm-hmm.
So you need to be able to invalidate those certificates as membership in the service changes. Whereas a client certificate for a pod / service account identity is like, doesn't have that problem.
So you, I guess that seems a little bit odd to me that you would worry about when a pod leaves a service, you would want to remove it, or when a pod is deleted, you want to revoke the certificate, or but you wouldn't for a client certificate, or
I would say
different.
When a pod leaves a service, other people shouldn't, or other pods should no longer trust it to offer that service. So like, we actually don't solve this problem at Google. We instead we only issue client certificates, and we build a mechanism that lets you check whether the client certificate you're talking to behind the service you're talking to is valid.
That's kind of confusing. I would say that it is more like there is a mapping of services to service accounts, and certs carry a service account identifier.
Yeah, okay.
So I think the thing with services is, they're loosely coupled to pods. Over time, pods may be added and removed to services. I think that has implications on potentially both sides. Like you have to update a pod's serving certificate to include new names. You have to revoke old serving certificates for pods that have old names if you want to do that sort of like degree of isolation. Another thing that we could do is just punt within namespaces, because pods can only back services in the same namespace. It might be like an okay path forward.
My thinking for the concrete first step was focus on mechanism for getting a certificate into a pod, and then we can experiment with like, okay, I want to think about service account certificates, or I want to think about serving certificates for a service. We can write a new signer that has some strategy for authenticating, for issuing those certificates. I don't know what that would be yet, but that's why I was focusing on the kubelet piece first.
Yeah, I think that's fair. I guess I don't know how others feel. To me, as long as you keep the serving certificates short-lived, some reasonable lifetime, I'm not stressed about revoking them. If you're part of the service, you're part of the service. If you were recently part of the service, whatever.
What about having to reissue
what?
Reissue certificates when services are created? Do you think that is problematic?
Could you be a little bit more concrete? Are you saying that like
you added, like, if somebody had like a service v1, service v2, or I've seen people like version their services by some like deployment, so it's like the creating new services and deleting old services happens frequently. Now each one of those events require refreshing all certificates across all pods within that back that service. Like, is that churn like something that we want to that we're okay with? Do those updates happen all at the same time? Seems like a potentially scary, impactful operation versus like what we have before. Does that make sense?
Yeah. So I think, David, correct me if I'm wrong, like in OpenShift, we kind of sidestepped this a bit just because we stored the serving certificate in a secret. So it was just mounted.
Right. You ended up having to say, I have this pod. I know this is the service that I want to have. I want it to serve for. You get to choose one, and it will create it in a secret, and then your pod just relies on that secret. There's no automatic injection, but it did make it very easy to go from I have this thing that serves, I need a certificate that other services are going to be able to trust, and I'm going to at least say that inside that this is contained to pods inside this namespace, and that got us a very long way. I do have to drop, but I can appreciate that if that is not the direction you wish to go, that might not be a useful step for you to move in. So
I'm interested in hearing more. Thanks everyone. Yeah, we're a little over time. So talk to you all in the New Year's.
Well, figure.
Oop.